This lesson is 5.6. We're going to be talking about two more methods of showing that triangles are congruent, ASA and AAS. So using two angles and a side will get us congruent triangles, but there's a difference between where that side is located. First, for angle side angle, or ASA, it's going to be two different angles, and then connecting them is the side that's included. So that would make it angle, angle with the side in between, or ASA. So if angle A is congruent to angle, would help if I wrote A. Angle A is congruent to angle D as our angle. Segment AB congruent to segment DE as our side. And then angle B congruent to angle E as our other angle. Then we have triangle ABC is congruent to triangle DEF. But the other instance is when we have two angles and what's called the non-included side, for angle, angle, side. So here, when I have two angles and I connect them, it's not the side that's congruent between them. It's one of the other sides. We do have to make sure that it's the same non-included side in both triangles. I couldn't have the side here match with the side here. That wouldn't work. So in this case, we have angle A congruent to angle D, angle B congruent to angle E, but instead of the side between them, we now have segment BC congruent to segment EF. And that is what would make triangle ABC congruent to triangle DEF. Recall the things we're allowed to mark in our pictures. We're allowed to mark vertical angles as being congruent to each other. We're allowed to mark right angles on one side and the other, which doesn't happen in any of these. We're allowed to mark congruent angles for parallel lines, which doesn't happen in any of these. And we're allowed to mark a shared reflexive side. So now that these are all marked, this would be an angle, this would be an angle, this dash would be a side, connecting the two angle corners together, passed through the S, so this would be by ASA. In the next one, this is our S, here's our A, here's our A. If I connect the two A's together, it does not touch the S, so this would be AAS. Here's an angle, here's a side, here's an angle. Connecting my two angles together does not touch the side, AAS. And here I have angles, I have a side. Connecting my A's together does touch the S, so that's ASA. So here's two for you to try. You could pause now if you'd like. The answer is posted on Google Classroom. So in example 2, let's not make it big yet. We want to determine if the triangles can be proved congruent, and it could be any of the 5 methods now. So the 2 new ones from now, or the 3 old ones from before. We'll explain why or why not, and if they are, we will finish the congruent statement. So in choice A, I know I can mark a reflexive side, and I have 2 different sets of parallel lines. So I could say angle 1 and angle 3 are congruent by alternate interior. Angle 4 and angle 2 are congruent by alternate interior. So now this is an angle, this is an angle, this dash is a side. Connecting the 2 A's together past the S. So this is ASA. And for my congruent statement, triangle WXY, so W started with 2 marks, other triangle, 2 marks is Y. Then I went to X with no marks, so I would go to Z with no marks, and end at W with the 1. For our next problem, I know I'm allowed to mark my reflexive side, and that's it. So now I have an S here, I have an S here, and I have an S here. So that's 3 S's, SSS, which is one of our methods. So triangle SET, so S was between 3 and 1, between 3 and 1 in the other triangle was E. Then I had gone to E, which was between 2 and 1. So between 2 and 1 is S. And ending at T, we're going to end it at D. For part C, I have a reflexive side that I can mark, and that's it. So this is an S, this is an S, and this is an A. This looks like ASS because connecting the S's together does not point to where the angle was, but it is ASS in a right triangle, which converts it to HL. So triangle PIG would match triangle RGI. In our next problem, we can mark our vertical angles. So this is an A, this is an A, and this is an A. There is no theorem that uses only angles. So that's just no. We won't finish the congruent statement because it doesn't work with AAA. Part E, I know I'm allowed to mark vertical angles are congruent to each other. So now this is an S, this is an A, this is an A. If I connect the two A's together, it didn't touch the S, so that would be AAS as opposed to ASA. And triangle EFI, so 1, none, 2, 1, none, 2 would be HGI. And for our final one, I know I'm allowed to mark my reflexive side. So this is an S, this is an S, this is an A with the curve. Connecting the two S's together pointed it where the A was, so this could be SAS. So triangle XJC, so X was the furthest, would go to RCJ. So here's a check-in with some for you to try if you'd like. Pause. Answers can be found on Google Classroom. So we also have proofs. Again, we are given that segment AB is parallel to segment EC, and step 3 says given, so that's segment BD is congruent to segment BC. And they have, in fact, already marked that for me in the picture. I also know I can put that triangle ABD is congruent to triangle EBC. So if I knew I had parallel lines, and now I'm saying that angle D and angle C are congruent, that's because those are alternate interior angles, and that's the alternate interior angle theorem. Step 4 says I'm going to use the vertical angle theorem. In my picture, these are my vertical angles. So that's angle ABD and angle EBC. And now I can say my triangles are congruent. So that was an A, that was an A, this dash was an S. Connecting my two A's together passed through the S. So that makes it ASA. Here's a check-in for you to try. Pause now if you'd like. Answer is posted on Google Classroom. Here's example 4. We are told that angle F and angle K are right angles, which is here in step 3, so that's given. And we are told that segment HF is parallel to segment GK, so that is also given. And we know the final step would be triangle HFG is congruent to triangle GKH. So we are given we have a pair of parallel lines. So these parallel lines, if I trace them, allowing me to see that my alternate interior angles should be these two. So that's going to be angle FHG and angle KGH. We were told that we had right angles, and now we're using the right angle congruence theorem, which we haven't used much. We learned about it, but we haven't used it. But the right angle congruence theorem just says right angles are congruent. So if I know angle F and angle K are right angles, I could say angle F and angle K are congruent. And then we have that segment HG is congruent to segment GH. In my picture, that would be a reflexive shared side. So my final step is to say why my triangles are congruent. This was an angle here, this was an angle here, this was a side. If I connect my two A's, it didn't touch the S, so this would be AAS. So this is one final problem for you to try. Answers are posted on Google Classroom. But that is it for section 5.6.